So for the third one, yeah, I think I went kind of quick here. So again, right, we have our polynomial here, right? We have 3x cubed minus 4x squared minus 9 times x plus 10, right? Okay, so that's our quotient, that's our dividend. So again, it's already in standard form. We're not missing any terms, right? So we don't have to use 0 as a placeholder. We also have x minus 8. So the 8 comes here. This 3 goes here. Minus 4 goes here. Minus 9 goes here. And 10 goes here. So here's the 8. So what we do next is the 3, right? That just comes down. And just like before, right? We have 8 times 3 is 24. Okay? Minus 4 and 24, that's 20. 8 times 20 is 160, right? It's always, you multiply, the product goes to the right and up one, so to say, to the column to the right, up one row, and you add the numbers. You get 151. 8 times 151, this would take like a calculator or something. So from here to here, if you multiply, you would get this, 1,208. So you could just check that in the calculator if you want. I definitely did not do that by hand. And then you add to get 1,218. So, okay, so what does this tell us? The quotient then is this. In other words, these give you the coefficients of the quotient. That's 1 degree less. So that's 3x squared plus 20x plus 151. Okay? Not only that, the remainder is here. So altogether, this is our polynomial. We get x minus 8 times the quotient plus the remainder. You can see also that, x minus 8 is not a factor of this because our remainder is non-zero. You could actually, if you wanted to, I'm not saying you have to do this as a check, you could multiply these out if you wanted. If you were to do that and add the constant here, you should get this original thing back. In other words, you could multiply this to see that the equation still holds. So, hope that was better. Let's see. Okay. Oh, there it is. Let's see. Was that better or? Let me see. Was that better? I had a feeling I went kind of quick with those examples. Sorry about that. I don't know what happened. I guess I went to autopilot without thinking, if that makes sense. All right. Is there any other examples you want me to do again? Any one of those 4? Because if there was something you missed, don't be afraid to ask. Someone just asked me to do the third one again, and I was more than happy to.
Can you do the second one again?
Sure. Okay. Be happy to. This one, yeah. Okay, so again, it's the same idea, right? We have, what do you call it? We have a leading coefficient 1, okay? Right, that's here. There's no x to the 4 term, right? So because of that, we have 0 as a placeholder. The minus 4, that's here. The 2 goes here. 4 goes here. 7 also goes here, right? Again, we're just, putting the coefficients in. 0 is, the placeholder. We have minus 6, as you can see. The 1 we bring down, right? And we do 6 times 1. That becomes 6. Okay? 6 plus 0, that's why 6 is still here. 6 times 6 is 36, right? That's why this is here. Now, if you were to add this to minus 4, you get 32. 6 times 32, that's 192, right? You know, you could do the calculation on a calculator or something. Some of these I did with a calculator. 6 times 32 is 192. Add 2, you get 194. Times 194, that's 1,164. That I definitely did on a calculator. You can add 4 to that to get this. So the numbers are changing, but the process is basically the same. 6 times this number here, 7,008. We add 7, and we get this. And so from here, we have our quotient. I mean, the coefficients of it we have. It's degree 4. It's 1 degree less. And we have x to the 4, 6x cubed, 32x squared, 194x, 1,168. Here's our remainder. And so again, using the division algorithm, writing it in the last form, we have our original polynomial is x minus 6 times quotient, as you can see, plus our remainder. I think we're actually out of time now, but I hope that was better.